Okay, hi everyone. I hope this video finds you well. So today we are going to talk about variables, something we waited for. We are going to talk about declaring variables and the variable schema. So variables affordances. What are they? So variables keep track of information that is changing. They are used to calculate other values that is needed by the user, used to make decisions about what to do in loops or conditionals, used to keep track of what to display for a user, can be used for any combination of the affordances above. So the main operations of the variables, which is a named memory location of particular type, those operations would be override what is currently inside of that location or retrieve the values currently stored in that location. So how does a computer store things since we are talking about storage? Yes, it's binary. The computer is storing things in binary, zeros and ones. So how does a computer know where things are? Remember the fetch, decode, execute cycle? It's using that. It's using the fetch, decode, execute cycle to fetch where the instruction is stored. So it's basically like a mailman. Each RAM location has an address, and what is the only thing computer understands? Binary. So the computer keeps track of things with a numeric address. So just like the postman, the computer uses the address to find where to deliver the mail. So if computers just use addresses, why don't we do that in our code? Why don't we use just addresses? Because of many reasons. The most important reason is that if we are using addresses, which is basically numbers, and often used or expressed in hexadecimals, this is going to be a very hard for programmers to use directly, very hard to remember, right? So typically, each address location holds 8 bit. That means like 1 byte of data. It was entirely up to the programmer to interpret the meaning of the data, such as integer, real number, characters, or strings. And we are going to talk about these things later in this lecture. I stored some great data at this address 90000004. At least I think that was where it was. So I don't know. Maybe that was the location. We don't want maybe in our programming. You have to be very accurate. So, why do we need variables? It's easier for us to remember names rather than remembering numbers. So, a variable is named memory location that can store value of particular type. So, it's easier to remember that, oh, I use the word sum as a variable name to store something of type integer. Integer is a whole number. I used age to store something of type short. Short is also a whole number with smaller size. I use the average for the average number of points in my class, and so on. So basically, using those things, names, is easier than using addresses or numbers. So data types. So a C++ variable must be declared with a data type. The data type specifies the type of data a variable can hold. So you're asking now, what basically is a type of data could be? So basically it could be integers representing whole numbers, floating point numbers, continuous numbers, characters, or boolean. Remember boolean for false or true, the result of boolean expression. So they're also called, the data types, they're also known as fundamental data types because they store fundamental types of data. So C++ has two major categories of value types: integral types and floating point types. Integral, basically those are whole numbers or things that can be represented with whole numbers. Basically it's discrete data. Discrete data can be numeric, like numbers of apples. So these are discrete whole numbers values, like 1, 2, 3, 4, or the negative of that, -1, -2, -3, and so on. Or true, false, because those are actually represented as 0, 1, 0 and 1. Or characters, because those are represented eventually in ASCII numbers. Floating point decimal numbers, those are continuous data, can occupy any value over a continuous range, like 2.6, 2.7, -1.5, and so on. So fundamental types could be the integral, character, boolean, short, integer, or the Microsoft specific keywords like int8, which is basically equal to byte, int16 equal to short, int32 equal to int, and so on. So long and long. The floating point types are going to be float, which is the smaller size of floating point numbers. The medium size, which is the default, is double. And the bigger size is long double. The long double. So basically, type long double is a floating point type that is equal to type double, but it's basically going to be used sometimes to store or to get higher accuracy or higher precision. So the default data types are going to be character, int, and double. Character for characters, A, B, C, D, and so on. Int for integers, for whole numbers. Double for floating point numbers. So why do we limit the size of numbers? Why do we say, oh, the character is 1 byte, the short is 2 bytes, int is 4 bytes, and so on? Why do we say that? So basically in math, there is no limit to the size of integer, but that is in math because we are living in an infinite world, right? So why do you think we should limit the size of integers or any data type in programming? Because we do not have infinite RAM. This allows uniform commands to be carried out. To allow a number of any size, then different amount of memory would be needed, because that would make me save some memory. If I know that the range is going to be from 0 to 127, then I should use bytes, right? If I know that I need a number up to like 2 billion, then I use int. If I need just to store characters, the character is represented by 8-bit size. So I use 1 byte for it. So thus, needing many different commands for these numbers of different sizes. So variable names. This is a very important slide. You should memorize this. So a variable name identifies a variable. Always choose a meaningful name for variables. I don't want you to choose x1, x2, x3. x1 is storing sum, x2 is storing, for example, the average, x3 the username. That doesn't make any sense. Call them by what they are: sum, average, username. So basic naming conventions are the first character must be a letter, upper or lowercase, or an underscore. But basically the underscore has special meaning, which you're going to recognize later. May contain numbers, but not as the first character. The first character cannot be number. Name cannot contain spaces. You cannot have spaces. Instead of spaces, you can have underscores. So if I do username, I can do user, then underscore, then name. That is underscore. A space is not allowed. Do not use C++ keywords or reserved words. What are those? You have plenty of them. A reserved word would be part of the C or the C++ language. For instance, return, or the word using, or std. So it's not something you can ever redefine and cannot be used as identifier such as variable name, function name, or anything else from what we create. So C++ reserved words are a lot, like double for floating points number, int, return, using, this, size of, static, public, a lot of them. So C++ is a case-sensitive language, and this is very important. So this variable name is very different from this one, very different from this one. Those are three, those are not. Yes, the three of them mean result, but they are different because they have changes. Like this one is all caps, this one starting with caps or uppercase, this one is all lowercase, case sensitive. So remember those things. Here are the conventions plus case sensitive and do not use reserved word. Okay, so valid or invalid, is this legal? And is it a good choice for name? So is this valid? This one, this one, this one, this one. So spend some time to think about those. So pause the video, think about those, and then come back. Okay, here is the result. This one is valid, and it's okay. Yes, we tend not to start with underscore because it should have special meaning, like they use in networking and all these things. But it's still valid. This one is valid, but it's not meaningful, so it's not good. You start with number or digit, then it's invalid. This one is very good. If you have two-syllable name or like first name, two-word identifier, you can capitalize the second word, or if you have three-word identifier, you can use capitalize the other words, but not the first one. So this one is valid when we name a class, which is something you would know in CS132. This one is invalid because it's a reserved word or a keyword. This was invalid because it has a space. You cannot have a space. So how to define a variable? You first start with the data type. Int represents a whole number. So this code creates a spot to store information. What kind of information we want? The data type says it's int, so this variable is going to hold a whole number. Then you choose a good variable name. So you can use the name to perform one of these two possible operations. Overwrite what is currently inside, or retrieve what is currently inside. Overwrite, change the value inside. Retrieve, read the value inside. So assignment operator. The assignment operator is this, the equal. In math, it's equal. In C++, it's storing. It's storing something in something else. So storing 1 in variable. So var is the name of the memory location you chose. The 1 is the value. And the assignment operator overrides the named memory location, which is this one, var, on the left with the value on the right. And always we end our C++ statements with a semicolon. Okay, so if you want to define and initialize a variable in one line, yes, you can do that. You can choose the data type, the variable name, the assignment operator to store something. What is that thing? The one inside the variable. So that is going first, create a variable, then overwrites it with 1. Overwrites the value in var with 1. So here's another way. Instead of using the equal sign, which is from now on we are going to call the assignment operator, we can use the curly braces. The curly braces. This is storing 1 in var. So what level of precedence is the assignment operator? So if we have something like that, assuming that you defined var. When I say defined, you did something like int var before, and this is semicolon. Assuming that you did that before. So what level of precedence we have in here? So the operator that is going to be visited first is the plus. Why is that? Because if you have assignment operator, the right side must be completely evaluated before you assign the result of it to var. So the right hand side is going to be completely evaluated before we assign the value to var. So we have something called literals, a notation that represents a fixed value in the source code. It's almost available in every programming language. So, for example, for the integers, the int or long, we use 1, 2, 3, -1, -2. So basically the value itself. This is what we call literals. So for the integers, we use whole number. For floating point numbers, we use continuous data, like 5.1, 2.2, and so on. For strings, we use words surrounded by double quotations. Words surrounded by double quotations. Words surrounded by double quotation. It could be a 0 word like nothing, or 1 letter, or 1 word, or 1 statement, or paragraph. As long as you surround them by double quotations, those are called strings. Boolean values either true or false, and of type bool. Characters, those use the type char, and it's 1 letter only surrounded by single quotations. Yes, there are some exceptions for characters having 2, but if you have 2, it must start with the backslash, and it has special meaning. Like for example, \n is basically a new line. \a is basically alarm sound. It's different than this one. This one prints the letter A. This one, alarm sound. Something like this. So initialization using literals. You initialize x of type int with a literal 1. String caption with a literal number of people, and so on. Here are some examples. So let's talk about the variable robot mental model. So let's combine all 3 of these ideas: creating a variable, overriding a variable, and retrieving data. And retrieving the data from that variable into a fun mental model of how to think about variables. So imagine a robot that keeps track of a variable for your program. It carries out the orders you give in the form of the statements we just described. So a mental model is a kind of internal representation of external reality. So basically, that is hypothesized to play a major role in cognition, reasoning, and decision making. So we are going to talk about the cognitive load. So, but first, let's talk about how our robot is going to work. So initially, the robot just has a big empty block. Then you give the robot the command int a, which is create a variable named a of type int. So the robot responds by cutting the shape of integer and putting the label a on it. So the robot did that. Now we are going to say, okay, we are going to create another variable, int b. The robot is doing the same by cutting the shape for an integer, because it's of type integer, and putting the label b on it. So you give the robot the command b equals 6, which is basically assigning the literal 6 to b. So the robot responds by taking the 6, finding the opening marked b, and sliding it into b. Now you give the command a equals 3 plus b. But wait a second. The robot must find or retrieve the value from b first, right? So the robot finds the slot marked b and make a copy of the data stored there and then delivers it to you. So what you have on the fly right now is 3 plus 6. The robot is going to evaluate that and give you 9. After that, the robot finds the area labeled A and store the 9 into the slot A. So now you give the command b equal to. So the robot finds the spot B, takes it what's currently inside, throw it to the garbage, and replace it with with 2. Replace it with 2. So declaring a variables before using them in the Visual Studio is going to be a little bit something we are going to use, something you have used before actually when you defined a string for the username. But today we are going to define int, and we are going to do that this way. Int for the data type, width for the name of my variable. From the name, its meaningful name, it means that I'm storing the width of something. Then I'm doing putting 5 inside. Then doing the same, but now it's height. Then the area of my rectangle is gonna be width times height. So I can print the area is width times height. And system pose to pose actually. And this is basically int main. Int main. This system pose to pose the window on the console window after it shows the result. And that is int main because that int t main was old and int main is the one we are using. Okay, so this is actually how we declare the variables and this is how we use them. This is overriding the values inside and this is retrieving the values inside, right? Retrieving the values inside, doing the calculation 5 times 5, and then you would find 25 on the console. Okay, rules of variables. You cannot change the variable's data type. You cannot. You can change the data, but not the data type. So once it's a string, it stays string for the whole program. Once it's int, it stays int for the whole program. So a variable holds one value at a time. You cannot have more than one value. Because if you replaced the value, it's going to still having one value, their placed value. So string variables. String is a combination of 0 or more characters. And I just explained that in a couple slides back. So value of a string variable is assigned on the right of the assignment operator. surrounded by pair of double quotes, something like that. So assuming that you created strong product description, then you assign the string value. What is the string value? Words surrounded by pair of double quotes. So the following assigns the product description, the value in the product description, to a label control named product label. So you put basically, you retrieve the value from the memory, which is basically this value, and store it in product label. So you basically duplicate the value. So strong concatenation, if you want to concatenate, concatenation is the appending of one string to another, to the end of the other string. So C++ uses the plus operator for concatenation in terms of strings, if you're using strings. So if I want to have hello word printed, then I have string hello equal hello, then the message is going to be hello, which is retrieving this hello, plus word. But wait a second, this is not going to show hello world. It's not going to do that because it's not adding a space. However, it shows hello world combined. If you want a space, you either add a space after the O or a space before the W. So concatenation can also happen between a string and another data type, like int and a string, double and a string. Like here is it. This one is basically int, right? This is int literal. Plus apple, that is going to show, if you print message 2, that is going to show 12, a space, then apples, because there is a space in here. There should be a physical space. This space is not counted. This is not counted. There should be a physical space inside the quotations. Okay, there is something called widening conversions and narrowing conversions. Widening conversion is when a value in a smaller variable is assigned to a larger variable with no list of data, or when a value of a smaller literal type is assigned to a larger variable with no loss of data. So because widening conversion are always safe, the compiler is not going to issue any warnings. If you assign something from long to double, that is basically actually going from whole number to double floating point number, which is adding more precision. Boolean or character to any other, because this is basically the smallest, 1 byte. Going to any other thing is going to be widening, because any other thing is going to be bigger in size. Short to int long or long. Or any floating point number, like float or double, or long double. Wide character or word character to any of these two is going to be widening. Int or long going to long. Float going to double. These are the widening conversions. Narrowing conversions, converting from the bigger data type to a smaller data type, or the opposite of widening conversion, right? Converting from bigger data type to a smaller data type, whether that thing is represented by a variable or a literal. So the compiler performs narrowing conversions implicitly, but it warns you, so there is going to be potential data loss. And this is a very important statement. So take these warnings very seriously, because you may lose information. So here's an example of widening conversion, an example of narrowing conversions. So This is legal and you will lose no information if you are doing widening. Double price equal 5. 5 is going to be stored as double in price, which is basically the compiler is adding zero point 0 to convert that from, because this is basically integer literal, right? Storing that as double literal, it's going to be adding the 0.0, adding more precision to it. So this is legal if you're doing narrowing, but it will cause a warning due to a loss of data because this is basically double literal, right? So how to convert it to an int, how to store it as int, remove anything after the decimal point, just the 5. Anything before the decimal point, anything on the left of the decimal point. So operations between types, any operation, the plus, the minus, like addition, subtraction, multiplication, division, or module, between two of the same type will result in an answer of that type. So for example, this is basically int literal. This is int literal. The result is going to be integer literal. So if I have this cout 5 and 5 times 5, this is basically 25. The computer is going to deal with them as integer and integer. So any operations between two different types, the compiler will follow set of rules. This will convert the lower precision type to a higher precision type. Higher precision can store with more accuracy or more information. For example, 5.5, basically this is double literal. This is integer literal. Will result in 27.7 because the compiler is going to promote this one to 5.0, then do the multiplication and produce this result. So operations on different types is going to give some promotions. So for example, I'm going to focus on the highlighted rules because those are the ones you may see this curve. So if either type is double, the other is promoted to double. If either is float, the other is promoted to float. If either is long int, then the other is promoted to long int because this is the bigger size. Unsigned int and signed int is the bigger size. So doing that. If any of them is int, the other is promoted to int. So these are the things that you may see. So this one is the one we talked about. This one is double literal and this one is int. This one is promoted to 5.0. Then 5.0 times 5.5 equals the 27.5. So how many things you can think about at one time? This is why we use the cognitive thinking of the mental robot, right? So let's talk about the cognitive load. How many things you can think about at one time? So working memory can only hold 4 to 5 bits of information at one time. Information in the working memory lasts only around 10 seconds. So these are scientific information. Approximate number of seconds and approximate number of bits. So we construct new schemas, mental structures for how things work in working memory so they can be integrated into existing knowledge and long-term memory. So the cognitive load refers to the total amount of mental activity imposed on working memory in any one instant, any moment. So schemas can get automated if they are repeatedly and successfully applied. Automated schemas are not consciously processed in working memory. They free working memory capacity for other activities. Some types of schemas that become automated are reading and driving a car. Sometimes actually I ask myself, how did I get to my home from work? I was driving and I didn't know that I was paying attention to every detail in the road while driving, because that was in the long-term memory because of practice. So practicing simple problems repeatedly until they are second nature will lower the cognitive load. So exercise time. So to reinforce these ideas, let's try a few exercises together, and I will leave you some exercise on Canvas so you would go do them. So list in order the steps that happen. Example 1, int age equal 5. So the compiler is going to create int size memory and call it age. Then 5 overwrites the value stored in space called age. So this is the schema, right? This is the scheme. So example number 2, int age equal 2.2. Again, the compiler creates a int sized memory and call it age. And then since this is int and this is double literal, the compiler find itself confused. Then the easy way to do it is to narrow the 2.2 to 2. So a narrowing conversion is applied of the 2.2 to a 2. And 2 overwrites the value in age. So 3 steps. So bool valid equal true. 2 steps. Creating bool size memory called valid, and then true overwrites the value in valid, and valid is the memory name. So int width equal 9, int height equal width plus 7. So there would be 6 steps. The first one is creating width of type int, and then the second is going to be overwrite it with 9. 3, int sized height is created of type int. Value 9, because we have width, right? So we have to retrieve. And remember, if we have assignment, always do the whole thing in the right hand side before you do that to the left hand side. So retrieve width, which is 9. The value 9 is retrieved from width. Then evaluate the right hand side. So 9 plus 7 is evaluated to 16. Then 16 overwrites the value stored in height. Example 5. Bool datetime equal true, datetime equal false. So 3 steps. Create datetime of type bool. Assign it the true value, which is true overwrites the value stored in datetime. Then overwrites it again with false. False overwrites the value stored in datetime. Example 6 this is a little bit of confusing, not confusing to the compiler. It's going to be confusing because, as you can see, the compiler is going to throw an error. Why? Because you did the first one right. Inside member location is stored for created and called big number, so you're good. Then 500,000 overwrites the value in big number. Okay, we are good. We are done with this one. But then moving to the next one, the compiler is going to create another variable with existing name. That is a compilation error because big number has already been declared. Int width equal 19, height equal width plus 7. So this one, there is no problem in this one. Just following those two steps. Int size memory is created and called width. 2, 9 overwrites the value in width. Okay, but then where is the data type of height? So height has not been declared. So there is no data type. You can put this in the context you want, word it the way you want, but there is no data type for height. Whether you say height has no data type, therefore compilation error, or height has not been declared, or anything you want, as long as you explain why. So how do you think this is resolved? This one, this one, this one, and the plus operations among them. So basically, this is going to handle one operation at a time. So it's going to do this, always from left to right. Firstly, this. So 4 undergoes widening conversion because remember, double rules. 4 undergoes widening conversion, becomes 4.0. Then 4.0 plus 7.2 is evaluated to 11.2. Then we have 11.2 for this one, 11.2 plus 6. You can think of it this way. This is going to undergo widening conversion. So 6 undergoes widening conversion to be 6.0, then 6.0 plus 11.2, or to be more accurate, 11.2 plus 6.0 is evaluated to 7.2, or 17.2, sorry. And that's it. So conclusion, variables are used to keep track of information a program uses. You must declare a variable before you use it. You must. They have only two operations, override and retrieve. Practice. Think about what is happening as you create a variable, like the schema we have been doing in these slides, and the robot, the mental robot we were using. So the type of the variable affects how large a value is it can hold. Conversions from one type to another can lose precision. So follow the rules and remember the rules of the widening conversions and the narrowing conversions. Okay, that's it for today. See you in the next one.